In order to get rid of the mystery around computers, a great place to start is with the language of computers. So in order to get to know the language of computers, we have to know binary. So binary just means made of two parts. So in computers, we're talking about digital computers, of course. We're talking about electronic devices, right? We plug them in, and these circuits, these chips, right? These signals, they're really what make the computer work. So really, when we're talking about electrical signals, there's only two states. The signal could be on, or it could be off. Now, if we're going to represent this on and off state with actual, numbers or some kind of language, we're actually going to go with zeros and ones. Just like we have a decimal number system, so humans we count using tens, right? We go 1 through 9, and then we go 10. And then you have 10 sets of tens, you have 100. Now, why is our number system based on 10 as humans? Well, it's because we have 10 fingers. So think of computers as only having the two fingers. Now, of course, even if you have two fingers, right, you can continue to count with those two fingers to represent any number you want. And then with those numbers, right, if you have enough of them, you can actually represent uh, useful information. For example, audio data, visual data, right, like videos and pictures. Pretty much anything you can think of that a computer can do is actually can be translated down to these zeros and these ones. So, like I said, electrical signals on or off. Off is represented by a zero. Zero means empty, right? Of course, it's going to mean off. And then if we want to represent the on state of one of those electrical signals running through our computer, then we're going to use the number one. So these on or off states represented by the binary numbers 0 and 1. In binary, there's only the two numbers. Remember, binary, two states. So 0 and 1 is naturally the ones we go for. Of course, we could have gone with 1 or 2, right? But as you'll see with most concepts in computing, we do start counting with 0 a lot. I'm not exactly sure why. There must be some mathematical reason to that. But just know our starting point is 0, our second number is 1, and that's it. We just have two numbers when we're referring to the binary system of numbers. So like I said, any number that you represent with decimal numbers, you can represent with binary numbers. Because even if you have two fingers, you can continue to use those two fingers, right, to count over and over again. Just like we only have 10 fingers, but we can represent really big numbers like 1,000, 10,000, a million, and so forth. So as you can see here, right, this picture, the on state, that means there's a signal that's on. You represent that by a 1. Off state, that's a 0. So here's a visualization of how you can actually count using binary numbers. So they're flipping this little cool carpentry like tool slash toy. And as they flip through those numbers, those little tabs will actually go to the next digit. So just like with regular fingers, right? Once you run out of your 10 fingers, you throw a 0 at the end. Well, that's kind of what's happening with this counting tool, right? Once you run out of those two fingers and you need to represent a bigger number, you're going to go to the next digit. So you don't need to understand exactly what's going on here. If you do take, advanced programming courses, you are required to learn binary. So I learned how to actually translate regular numbers to binary numbers, back and forth. I even learned another system called the hexadecimal system. For this class, you won't have to do that. Although we will have a little fun activity where you get to convert your name into binary. Of course, I'll give you a chart on how to do that, but it'll kind of just give you an idea how much space your name takes up on the computer and how the computer actually understands your name in binary. So speaking of number systems, right? I highly encourage you to watch this video on the history of numerical systems. So we have a number system of 10. Computers have a number system of 2. Back then, the Aztecs actually had a number system of 20. They'd use their hands and their toes to count. So of course, 20 digits, right? 20, 10 fingers, 10 toes, that's 20. So yeah, feel free to check out that video. Just kind of expands your mind, right, on there's not just one number system, there can be many.